So an identity is just any statement that's always true, like 2 plus 2 equals 4. Or sine x divided by cosine x is tangent x. Things like this, okay? So let's go through, basically I'm gonna give you a list of things that you can use in these proofs. Some of them will be more obvious than others, but you'll want these written down somewhere so that you have sort of like a bank of tools to use when you start doing some of these proofs. So basically I want to break these down into 3 categories. The reciprocal identities, which you probably already know. The quotient identities, which you might have seen before, but they're pretty intuitive, they're not too bad. And then the Pythagorean identities, which are ones you probably haven't seen before, but should make sense once we see like why they're true. So let's start with the reciprocal identities. There's 6 of them, and basically these are just algebraic equations, just sentences that are always true, that relate the different trig functions to each other, specifically the reciprocals. So as long as you already know what functions are reciprocals of what, these should be pretty obvious. So like for instance, sine theta is always equal to 1 over cosecant theta. Okay. Those are the same. So in our proofs, just know that you can make a substitution one way or the other if you need to. Similarly, cosine theta is always equal to 1 over secant theta. Tangent theta is always equal to 1 over cotangent theta. So those are the first 3 reciprocal identities, and the other 3 are just basically a rearrangement of these statements. So like if sine theta equals 1 over cosecant theta, you can also say that cosecant theta is 1 over sine theta. And you can make that statement for each one of these. So like secant theta is 1 over cosine theta, cotangent theta is 1 over tangent theta. So you can just think of all of these statements as tools to help you prove other statements. We also have the quotient identities. Now there's only 2 of these, and what they do is relate both tangent and cotangent to sine and cosine respectively. One of the strategies that we're going to go over is that sometimes when you're trying to do these proofs, it's helpful to write all of the trig functions in terms of just sine and cosine and kind of hope that things simplify out for you. So it's good to know how to rewrite both tangent and cotangent in terms of sine and cosine so you can do that. So for example, tangent theta is equal to sine theta over cosine theta. And there was that last problem that you asked me about on the homework needed you to make this kind of a substitution to be able to solve it. So giving you a little preview of what's coming up. Cotangent of theta, which is the reciprocal of tangent, should just be this fraction but flipped. So that's going to be cosine theta divided by sine theta. So all of those I think are pretty easy to remember, pretty straightforward. There are 3 other identities we're going to go over today, and they are called the Pythagorean identities. No, I can't spell. Wow. So there are only 3 of them, but I'm also going to show you how we can rewrite them or rearrange them a little bit. In some problems, they might be more useful written one way or another. So the first one, which is probably the easiest one to remember, and this is actually, I think this one's pretty neat, like why this is true. Anyway, so we have cosine squared theta plus sine squared theta What do you think that's equal to? Tangent squared theta? Unfortunately not. But think about like these triangles on the unit circle. You don't have to write this down. I'm probably going to erase it, but just so you can see, you know, here's like in the first quadrant, just to give you a quick example. Let's take a point here, draw a triangle. If this is cosine x, and this is sine theta rather, what is cosine theta plus sine squared, cosine squared theta plus sine squared theta? What should that equal? Oh, on the unit circle, what is this? It's 1, right? So cosine squared theta plus sine squared theta, no matter what coordinate you're talking about, no matter what the angle measure is always equal to 1. Now that's going to be helpful even past this year and into calculus, is knowing this guy right here. Maybe I'll keep that little diagram in there. I kind of like that. So you can rearrange this if you need to, and you'll see cases, and we'll get into some examples on why you would want to rearrange this. But you could also say, as a corollary to this, that sine squared theta equals 1 minus cosine squared theta, right? Like if you were just to subtract the cosine squared theta, you could get another equivalent statement. And you could also do the same thing by subtracting sine theta. So this is also true. So these are just sort of variations on this Pythagorean identity. There are 2 more. Okay, the next one is tangent squared theta plus 1 equals secant squared theta. This one's probably not as obvious, but still true. The variations on this is, like you could say 1 equals secant squared theta minus tangent squared theta. And also you can solve for tangent squared if you needed to, and that'd be secant squared theta minus 1. So just like the first Pythagorean identity, you've got a couple different ways how you can rewrite this one. They're equivalent, but just rearranged a little bit. And so the last one, let's see, what trig functions are we missing here? Cotangent and cosecant, I think? Yeah. So we've got cotangent squared theta plus 1 equals cosecant squared theta. And you can rearrange this one in the same way we rearranged the last two. For example, you could have 1 equals cosecant squared theta minus cotangent. You don't have to memorize all of these variations. I mean, you have to know your algebra well enough to be able to use them. But really, these 3 major ones are the ones you probably need to memorize. Right? The rest of them you should know already. If not, you might need to work on memorizing those too. And then once we get into the examples, you'll kind of see how we use them. We could also subtract 1 from either side on the original one to get cotangent squared equals cosecant squared minus 1. So these are all the identities that we are going to use for today in terms of trying to prove statements to be true.